Hello, all, and thank you for joining us today. We're going to give everyone a couple more minutes to join us before we begin. Okay, and we are going to begin. Thank you all again for joining us today to learn more about Hasakawa Custom Processing Services and how we can help optimize your material processing needs. Our presenter today is Mr. Rob Voorhees, President of Hasakawa Custom Processing Services. With over 45 years of industry experience, he brings valuable insight into our advanced processing solutions. As a reminder, this webinar is being recorded and will be available on the Hasakawa Custom Processing Services website. We encourage you to submit any questions using the Q&A tab. We'll address as many as possible during the session, and any unanswered questions will be followed up via email. Let's get started.
Good afternoon and welcome to our presentation on the processing services offered by Hasakawa Custom Processing Services. My name is Rob Voorhees and I will be your presenter today. Today's presentation will be focused on the size reduction with air classifying mills. Hasakawa Micron made a major investment in a new facility dedicated to providing our customers with state-of-the-art processing services. In 2024, we opened our new processing business in Goldsboro, North Carolina. And this is a view of our brand new facility in Goldsboro. Going forward, I'm going to refer to the company as HCPS. The new facility is uniquely suited for our processing business. This 50,000 square foot building sits on 19 acres of land in the Park East Industrial Park located in Goldsboro, North Carolina. We relocated several processing systems from our plant in New Jersey, and we have made substantial investments in new equipment to expand our processing capabilities. The major portion of the facility space is dedicated to various processing systems, warehouse space, and future systems installation. We now have 11 installed systems available to our customers for a wide variety of processing services. This is a partial view of the processing area at Hasakawa Custom Processing Services. In the foreground are 3 systems for size reduction and micronization. Further in the background are additional systems providing size reduction, blending, and screening operations. A separate area is dedicated to recycling and granulation. Each installed system has its own nuisance dust collection points at specific locations to ensure a dust-free and clean processing environment. All systems are designed for the processing of high KST value materials and each system is protected by a suppression system designed to prevent dust explosions related to the processing of organic materials or other chemicals that are potential hazards. The Goldsboro, North Carolina location was chosen for several reasons. However, the most important was access for our customers. Over the last decade, the southeastern sector of the United States has had the greatest growth in the country for companies establishing new businesses and manufacturing facilities. In addition, many companies have relocated to the southeast, and in particular North and South Carolina, due to the many benefits and quality of life opportunities these states have to offer. Principal among them is a strong technical labor force and an overall lower cost to do business. Hosokawa Custom Processing Services is strategically located in close proximity to the major north-south corridor of Interstate I-95. We are also 1 hour from Raleigh International Airport with access to domestic and international destinations, and the major seaport of Wilmington, North Carolina is 90 miles to the southeast of Goldsboro for the importation or export of materials from our international customers. ACPS offers a range of services for the processing of chemical, mineral, and polymer materials. The services we offer include several different types of size reduction technologies, screening, blending, compaction, packaging, particle size analysis, and particle characteristics analysis. We conduct feasibility testing to ensure we can meet the specifications, quantity, and quality of the finished product you require. When customers are ready to commit to large-scale orders, we then process their materials at our Goldsboro facility. John McGovern is the manager of the business and has over 35 years of experience in the industry. We have a staff of 14 technicians and 2 maintenance personnel, and we currently operate 2 shifts 5 days a week. Today, we want to focus on the unique capabilities of the air classifier mill, also referred to as the ACM. The first versions of this design appeared in the 1960s and was the first mill of its type to incorporate both milling and classification in one machine. With the capability to both mill and classify, these mills are able to produce narrow particle size distributions with excellent particle top size control. Due to the design of the impact zone and grinding elements in combination with the highly efficient internal classifier, very fine and narrow particle size distributions can be achieved. The micro ACM operates in the fine size reduction category shown here in yellow. It can process many materials to a top size of 20 microns and to a D50 of 6 to 8 microns and finer in some cases. Because of its unique geometry, numerous design options, and the superior design of its internal classification system, the micro ACM is the finest, grinding, and most versatile mechanical impact mill we have installed at HCPS. At HCPS, we have several ACM systems available for project development as well as large-scale production runs. Our 2 ACM is capable of handling several kilograms of material for short test runs and project development work. Our 15 and 40 ACM mills are utilized for larger scale processing and can process hundreds of pounds of materials an hour. For handling abrasive materials with a Mohs hardness of up to 4, these mills can be provided with wear-resistant components. For handling materials that present an explosion potential, these ACM systems are designed to suppress any overpressure caused by a potential explosion. To ensure maximum availability, these systems are inspected on a regular basis to minimize maintenance requirements and reduce downtime for maximum efficiency and productivity. Not only do these mills produce materials with a very fine top size, but the particle size distribution and the generation of ultrafines can be controlled. Top size control is accomplished with a unique internal recirculation and classifier system. With the shroud and baffle assembly removed, you can see here both the impact rotor and the classifier wheel inside the mill housing, providing a very compact design. Ultrafines can be reduced by alternate mill configurations and different processing parameters. Control of the particle size distribution can be accomplished by varying a combination of airflow, classifier speed, and impact force of the main rotor. ACMs can handle many different materials, including the processing of heat-sensitive and abrasive materials, and production machines can process large volumes of material in a short period of time. As its name indicates, the air classifier mill requires air to function. Air provides the motive force to convey material to the mill, classify the product into fine and coarse fractions, convey the fine material out of the mill, and then return the coarse material fraction to the grinding zone of the mill for further size reduction. This process is repeated on a continuous basis during the operation of the mill. The unique feature of the ACM mill is that the classification step takes place inside the mill and is not a separate or external operation. This design allows these mills to be relatively compact in size, requiring less floor space for a system and less equipment to clean for the relatively high production rates that they can achieve. The main airflow is introduced from underneath the main rotor disc. Material is introduced into the grinding chamber at the grinding zone and is impacted by the rotating hammers. The grinding and classification zone are normally separated by the shroud or internal baffle. The impact rotor and classifier have separate or independent drives so that the speeds of each component can be adjusted independently. Let's review the basic components of the mill in more detail, starting at the beginning of the process. The main airflow is introduced from the lower side of the mill base from under the rotor. Just below the rotor is an elutriation ring that provides a narrow passage for the air to pass through on its way to the grinding zone. This narrow orifice creates a pressure drop, which produces a uniform distribution of the airflow around the rotor disc as it rises vertically up into the grinding chamber above. Material is introduced into the grinding chamber through the feed inlet port. Material can either be air conveyed or gravity fed into the mill, utilizing a device such as a volumetric screw feeder or rotary airlock feeder. In the case of air conveying, as much as 20 to 25% of the total system flow can be diverted from the main airstream of the system to assist in conveying of the material into the mill. Usually materials that are very coarse or that have a high bulk density are more easily fed to the mill by means of a mechanical screw feeder or by gravity. Material is introduced into the grinding chamber and is impacted by the rotating hammers. The rotor disc has a number of impact hammers attached to the perimeter face of the disc. These hammers provide the impact force that results in the fracturing and size reduction of the particles. The number and type of impact hammers will vary depending upon the application. Since the impact force of the hammers are directly proportional to the speed of the rotor, our ACMs have the rotor speed set to achieve maximum possible impact force to achieve the most efficient size reduction. The multiple deflector liner assembly for an ACM is shown here. The liner acts as a replaceable impact surface for the size reduction operation. The liner assembly typically will be provided with grooves milled into its surface. The purpose of these vertical grooves is to impede the circumferential speed of the material leaving the hammer face and to deflect the material back into the hammer path for additional impact and enhanced size reduction efficiency. Other liner designs are available depending on the requirements of the application. The grinding and classification zone are separated by the shroud and baffle assembly. The vertical shroud separates and isolates the classification and grinding zone and effectively assists in recirculating the mixture of air and coarse particles back to the grinding zone. The baffle vanes mounted on the exterior of the shroud serve the purpose of redirecting the dominant radial velocity of the air and material component generated by the rotating hammers into a vertical trajectory. The mixture is then redirected 180 degrees by the dispersion ring at the top of the grinding chamber, allowing for a more uniform and favorable flow of the air material mixture to the face of the classifier wheel. Different shroud and baffle designs can also be provided depending upon the application. Milled material is carried by the airstream to the classifier wheel. Correctly sized material passes through the classifier and exits to the volute assembly above. Oversized material is rejected by the classifier as returned to the grinding zone by passing underneath the shroud. The classifier shown here has a separate drive so that the speed of the classifier wheel can be adjusted independently to control the cut point of the material. Many different classifier wheel designs are available, again, depending upon the requirements of the application. Correctly sized material passes through the classifier and exits the mill through the volute assembly located on the top of the mill. The material exits the mill through a radial outlet. The inset on the right shows a classifier and the volute assembly of a large ACM. On a coaxial mill design, there is no volute assembly and the material exits the mill directly at the cover outlet, shown in the photo on the upper right. We should discuss in more depth the theory behind the classification technology used in these mills. This diagram shows a top view of a radial bladed classifier wheel. The various forces that come into play during the operation are listed on the diagram, and the formula for this calculation of the relative cut point is shown. The yellow dot represents a single spherical particle. You can see that there are two forces at work on this particle as it approaches the classifier wheel. There's a drag force generated by the airflow traveling toward the wheel, and there is also a mass force or centrifugal force generated by the rotating classifier wheel, which also acts on the particle. When these two forces are equally balanced for a specific particle mass, the particle will have a 50% chance of either being accepted or rejected by the classifier wheel. So by varying these forces, a specific particle size or cut point can be achieved. You can see from the formula that with all the values held constant, the cut point will vary with the square of the tip of the classifier speed of the classifier wheel. The result of this relationship is that a small change in classifier wheel speed has a large effect on the change in particle cut point. Several classifier wheel types are available depending upon the application. The number of blades, angle of blades, and the height of the wheel can vary to allow for different surface areas, changing the velocity of the air through the wheel and hence the classification performance. Material characteristics can affect the performance of the mill and the overall milling system. We have discussed the effects of different material characteristics on mill and system performance in past webinars. For a review of their impact on the system performance and design, please view our webinar on the basic size reduction part 1, which can be accessed on our website, hosakawaprocessing.com, as shown here on the slide. This is the layout of a basic micro ACM system. While the ACM is the main component of the system and provides the means for size reduction, a fully functional system requires several other components, which include a feeding device, a fan to provide airflow through the mill, a product collector to separate the milled material from the airstream, and a control system to control all the parameters of the system operation. In this system, the main air supply to the mill is split into two lines to allow for the pneumatic conveying of material into the feed inlet of the mill. In this slide, you see a basic flow diagram for an air classifier milling system. Typical operating parameters to monitor include feeder speed and capacity, mill classifier speed, mill main drive fan and classifier amperage, mill differential pressure, product receiver differential pressure, and system pressure and airflow. By monitoring these conditions, we can assess the ongoing performance of the mill system to make sure that your product quality is maintained. Loop controls are added to optimize our system performance. System airflow is maintained by measuring airflow through the system and then automatically maintaining the flow by adjusting the fan speed. Feed rate is typically controlled by measuring mill main drive amperage, varying feeder speed to maintain full load operation. Pressure differential transmitters maintain a fixed pressure drop across the product receiver, ensuring optimal filter performance. Examples of the variety of materials ACM mill systems can process and the particle size that can be achieved are shown here on the slide. However, ACPS has experienced milling hundreds of materials with the micro ACM. Adjustment of airflow, classifier speed, and mill component selection allow the attainment of many different particle sizes as indicated in these examples. Our mission at Hosokawa Custom Processing Services is to provide the highest level of service, support, and performance in the industry, and we can demonstrate this through our complete range of innovatively designed equipment and systems. We will continue to build upon the unique legacy of the ACM to improve, redesign, and repurpose it to provide exceptional solutions for scores of powder processing applications and bring our customers continuous state-of-the-art developments in machine performance and system design. This concludes our presentation for today. I hope you found the information presented today interesting and informative, and I thank you for your participation. We'll take a few questions, and as a reminder, this webinar will be posted on our website within the next 48 hours where it can be viewed again. Thank you for your participation.
Thank you, Rob. As a reminder, we'll address as many questions as possible, and any unanswered ones will be followed up via email. So we had a couple come in during the presentation. The first question was, what is the Mohs hardness up to for the materials that can be processed through the ACM?
So as I mentioned in the proposal, we have a typical cutoff point of around 4 to 5 Mohs hardness. We can wear protect the machines, but if the hardness of the material is much higher, the wear on the machines is too much, and we can use alternate milling type of equipment to process those harder materials.
What's the smallest amount of material that can be processed at lab scale?
As I mentioned, we have a 2 ACM system which can mill several kilograms of material on small quantities to basically tell us if we can achieve the particle size and distribution that you want. It won't give us a good idea of the capacity we can achieve on our production machines, but it will give us an indication of the quality of the product that we can produce on an ACM.
What is the achievable particle size distribution for D50 for graphite application?
Again, it depends a little bit on the material, but as I mentioned, in most cases, we can get down to below a D50 at 10 microns with a micro ACM.
And in regards to that same question, what is the particle concentration at the discharge of the bag house?
I'm not sure if I follow the question. So there should be no segregation from the point of its mill till it's collected. So there should be no variation in the particle size distribution as it exits the dust collector.
Okay. Is there a variability of feed particle size distribution? What would be the best practice of ACM processing if the upstream feed's variability cannot be narrowed further? Sorry.
So, the internal classifier controls the top size and overall particle size distribution. So what will happen, in general, if you have a coarse feed, the production rate will go down because the material has to have more residence time in the mill to achieve the final particle size that you're trying to attain. We like for maximum efficiency and productivity, we'd like to put as fine as possible feed material into the mill to get the highest throughput rates out of the mill.
Can it be cleaned to avoid cross-contamination?
Yes. In specific applications, like in powder paints, we have special mill designs that allow for much easier access to the internal components for cleaning. So the answer is yes. These mills, because of their compact size and the way they're designed, can be cleaned relatively easy, especially the smaller models.
What is the typical lifespan of the hammers and class file wheels? Any major components susceptible to wear?
Yes, of course, the hammers that come in contact with the material are a wear item. The liner assembly I mentioned in the mill is a wear item. The classifier wheel to a smaller extent is also a wear item. And wear typically depends on the hardness or the abrasiveness of the material and the volume of the material that's going through the mill. So, for instance, one of these machines can mill sugar all day long, and the components can last for months or even years, because of the um, softness of the material. If you get a very abrasive material, you're going to change components a lot more frequently. So it really depends on the material and the particle size you're trying to achieve.
Can elastomers and rubbers be processed with your equipment?
So we have different types of milling equipment for polymer materials because they don't fracture easily in impact type mills. So we have attrition mills as part of our program at HCPS. Um, Typically for rubber products, you can only go so fine, and then to reduce them ever further, uh, most often the applications require cryogenically grinding. So the material is basically reduced or frozen and then introduced to the mill for size reduction. But most commonly, that type of operation takes place in a hammer mill, and not in an ACM mill.
Is there a minimum batch size for pilot equipment, or can it process batches as small as 3 kg?
Yes, we can process very small amounts, but for development testing, we need more material because we might have to make several adjustments to the machine to hone in on the particle size and distribution that you're looking for. So we may use several kilograms at each run in order to get to the product that you're trying to achieve. So, while it can take very small amounts of material, we typically need more until we are able to develop the product that you're looking to manufacture.
And one last question, and then we will sign off of the webinar. Does HCPS, do they have availability and to conduct lab scale tests?
So we typically don't do a lot of lab scale testing. All our machines are much larger for production testing. What we typically do is if we require a test to be able to give you a proposal for your project, we would do small scale testing, typically at our facility in New Jersey, where we have some smaller lab scale equipment. And then we would, based on that information, we could provide you with a proposal, and then the actual processing would be done at this facility in North Carolina. But we typically do not do a lot of small scale work.
Thank you, Rob, and thank you everyone for joining us today. That concludes the Q&A session of our webinar. We hope you found the session informative. We look forward to the opportunity to partner with you and support your processing needs. Thank you.